Good day to all students and parents. Hello. It's my pleasure to welcome you to this short session. This session is going to be introduction cum lesson session. I'm going to do 4 things in this session. First, I'm going to introduce myself. Second, I'm going to tell you about my teaching career, teaching experience, how I conduct my classes, how I give homework, how I conduct tests and exams online. Third, I'm going to introduce one maths topic to the students. It is arithmetic progressions. I will write only 2 formulas from that topic, arithmetic progressions. Then I will take one real world example problem and show how that problem is solved using one of the 2 formulas that we would have written. And fourth and last, we'll have a question answer session in which students and parents can ask me questions. They can seek clarifications. And I will give you with a feedback form. So let's move. My name is Srikanth Kanitkar. I am from Bangalore. I am a postgraduate in mechanical engineering. And I am passionate about my subjects, which are maths, primary subject, physics, and chemistry. I have been teaching these subjects for the last 25 and more years. I teach with examples. I teach by probing the students to come out with answers. I don't tell everything myself. When I'm teaching, when I'm writing on the board, also when I'm solving a problem or when I'm explaining a concept, sometimes I intentionally commit mistakes, calculation errors, simplification errors, expanding the bracket error. Or in science, when I'm teaching physics and chemistry, sometimes I propose opposite ideas which are not going to work, which are basically incorrect. And I wait to see if my students can catch my wrong and correct me. So this way I ensure that students learn the subject rather than focusing entirely on their tests and exams. So my classes are extensive in terms of knowledge acquisition, but during review and revision and as the exams approach, the classes become more intensive with focus on the examination, how to tackle examination questions, how to manage time, and how to use some shortcuts to save time. My handwriting is very nice. I write equally well on a physical whiteboard, which you can see behind me, or even on a virtual whiteboard. And I am a stickler to time. My classes start on the dot. And homeworks and tests and exams, I conduct using Google Forms because Google Forms is free also for everyone. And in Google Forms, students can easily take a photo of their notebook answer solution and upload it. It's very convenient for me also in terms of opening the file, opening their image and grading the answer. So this is how I conduct my classes, homework, tests, and exams. Let's move forward. I am going to introduce the maths topic arithmetic progressions now. I'll be writing 2 formulas and I will solve one real world problem as I mentioned earlier. So let me share my screen with you. I'm writing the name of the topic here at the top. It's called arithmetic progressions, and usually we abbreviate this to AP. AP meaning arithmetic progression. Now, what is an arithmetic progression? An arithmetic progression is one specific type of number pattern in which consecutive terms will have the same difference, and we call that difference as common difference. So let me give you one or two examples, then you will understand what an arithmetic progression or an arithmetic sequence is. So look at these numbers which I am writing here. So first I will write 4, the comma, writing 7, comma, 10, comma, 13, comma, 16, and so on. Now this is nothing more than a number pattern. This is a sequence of numbers, but there is something very special about this list of numbers. So in this list of numbers, you can see that the difference between any two successive terms is the same. What I mean is, if I do 7 minus 4, that is the second number minus the first number, the result is 3. And if I do the third number minus the second number, 10 minus 7, the result is again 3. Similarly, if I were to subtract the third number from the fourth number, 13 minus 10, the difference is 3. Again, if I do 16 minus 13, the difference is 3 again. So that means this is a special type of number pattern. There are other types of number patterns also, but not all of them bear the same common difference between consecutive terms. So this type of number pattern in which the consecutive or successive terms possess what we call as the common difference. We call that constant difference as common difference. So in my example here, the common difference value was 3 and my first term was 4. So this type of sequence is called an arithmetic progression. Arithmetic progression is also called an arithmetic sequence. Okay, here I am writing another different arithmetic sequence only. This time I will start with 10. I'll make it simple for you. I'll take the next term as 20. Next term I'll take as 30. Next term I'll take as 40, and so on. Now you know this is an arithmetic sequence where the common difference, which we denote as D, is 20 minus 10, I can say, which is equal to 10. This is the common difference of this arithmetic sequence. Supposing I want to find out which will be the 500th term of this sequence. In this sequence, it is easy. My example is not so good. I mean, in this sequence, it is quite easy to find out which will be the 500th term. So let me take a different sequence. For example, I change my sequence to 10, and then I'll make it 16, and then I'll make it 22, and then it will be 28, and so on. So let me take this as a better example. Now this is an arithmetic sequence. In this arithmetic sequence, the common difference of D, I can say, is 16 minus 10, which is equal to 6. And everywhere else also you can see the difference is 6. And the terms are endless. I mean, it's an infinite arithmetic sequence. What if I wanted to find the 50th term of this sequence at once, suddenly? So suddenly I got interested in finding the 50th term of this sequence. 50th term. So let me erase this sequence. Let me erase this sequence, which I am not going to use. Erase this. And let's focus on this sequence, which I have written now. So I said, I suddenly became interested in finding the 50th term of this arithmetic sequence. How do we do it? Now we can't go on writing all the terms until we arrive at the 50th term. So this can be easily done with the help of a formula. So that formula I'm writing here. The formula is an is equal to a plus n minus 1 times d. This is the formula. Now what is what in this formula? The letter A here stands for the first term, that means 10. The value of A is 10 here. And the D here stands, okay, A is 10, and the D here stands for the common difference, which is 6. So that means A is equal to 10 and D is equal to 6. And then what is N? My N is 50 because I want to find out the 50th term. That means I am trying to find the value of A50. I want to find the value of A50. So I'm going to use this formula. An is equal to A plus n minus 1 into D, where A is the first term of the sequence, which is 10 here. D is the common difference of the sequence, which is 6 here. And n is the number of terms, which is 50. So A50 I want to calculate. So I can calculate A50 now by substituting all the values into that formula. And I will do it like this. A50 is equal to, my A is 10 plus n is 50. So 50 minus 1 times 6, the D value. So if I simplify this, if I do the calculation, this is 10 plus 49 times 6, which is 10 plus 49 into 6, let's multiply, 6 9 are 54, carry 5, 24 plus 5 is 29. And 10 plus 2, 94 is 304. So that means at once I was able to calculate the 50th term of my arithmetic sequence. I didn't have to write the entire list of 50 terms. I was able to jump exactly to the 50th term and calculate its value. So the answer is 50th term of our arithmetic progression is 304. So this is one formula. I said I'll write two formulas I had said. So one formula which I wrote and discussed just now is number 1, the formula to find out the nth term of an arithmetic sequence. An is equal to A plus n minus 1 into D. Formula number 1. Now let me write one more formula and then my real world problem will be solved using my second formula. Let me write my second formula. The second formula is Sn is equal to n by 2, bracket, I'm using big bracket, square bracket, 2a plus n minus 1 times d. What is this formula for? The letter S here stands for the sum. So this formula can help us to calculate at once the sum to n terms of any arithmetic progression. So again, the other letters mean the same thing. The letter A here stands for the first term of the sequence. The letter A stands for the first term of our arithmetic sequence. The letter D denotes the common difference of the sequence. And n is the number of terms to which you want to find out the sum. So this is the number of terms. If you want to find the sum of first 10 terms, n is going to be 10. If you want to find out the number of 20, sum of 25 terms, n is going to be 20. And this notation Sn means sum to n terms. sum to n times. Okay. Now let's see how to use this formula to solve a real world situation. Okay. Assume that your grandma is going to turn 75 after 2 years. Today she's 73. Today is her birthday. 2 years from now, 24 months from now, she's going to turn 75. Diamond jubilee. You want to gift her. And let's assume that you want to give a gift of rupees 7,500 to your grandma on her 75th birthday. On her 75th birthday, which is 2 years from now, 2 years from today, 75th birthday, you want to give her a gift of 7,500 rupees. You are going to start collecting, pooling up the money from today itself. So assume that you begin with rupees 100. You start with rupees 100 and you are going to pool up money for the next 24 months. For the next 24 months, you are going to pool up money. And at the end of 24 months, you want your piggy bank to have rupees 7,500. Now, you can't collect rupees 100 every month. In 24 months, it will become only 2,400. But you are large-hearted and you are going to pull up 7,500 rupees as a gift to your grandma. That means every month you are going to add some money. Every month you are not going to deposit rupees 100 only. You are going to add some money every month. So let us find out how much more money you have to add every month so that after 24 months, the amount becomes rupees 7,500 or it exceeds 7,500. You want the amount to become at least 7,500. So if I make a model of this problem using mathematical formula or equation, it is like this. My A is rupees 100 or 100. My N is 24, number of months. And I want to pull up a sum of rupees 7,500. This is my objective. And I want to find out what is that additional amount that I have to add to the bag so that the amount exceeds or becomes equal to 7,500. So this can be solved using our SN formula. Like this. Sn is equal to n by 2 bracket 2a plus n minus 1 times d. Formula. 7,500, I am plugging in all the values. 7,500 equals 24 divided by 2 into bracket 2 times 100 plus 24 minus 1 times d. So that d remained d only. So d is what we want to calculate. I'll simplify this. 7,500 is equal to, this is 12 bracket 200 plus 23d. I'll take the 12 to the left hand side. Taking the 12 to the left hand side. So it is 7,500 divided by 12 is equal to 200 plus 23D. We'll divide this 7,500 by 12. So the 12 6 are 72, 30, 12 2s are 24, 12 5 are 6. 625 is equal to 200 plus 23D. So 625 minus 200 is going to be equal to 23D. So 23D is equal to 425. So I continue here. D should be 425 divided by 23. And if you calculate this value, 425 divided by 23, you are going to end up with an answer something like, let me do it actually here. 425 will be divided by 23. 23 ones are 23 is going to be 19 and 5. I think this will go maximum 8 times. 8 3s are 24, carry 2, 16 plus 2, 18. So this is 11. And then take a 0. 23 4s are is 92. And then I have the 8, 80, 23, 3 is 69, and we'll end it there. So D is 18.43 approximate. Not an exact answer because the denominator 23 is a prime. 18.43 approximate. That means every month you should be adding, you should add at the end of every month, or every month when you deposit the money, you should deposit 18.43 more than what you had in the previous month. So this is a common difference of our arithmetic sequence. What it means is your deposits are going to look like this. Your deposits are going to look like this. So first we started with 100. Next month, you are going to save 118.43. May sound odd, but I mean, it's just an example. So first month you saved rupees 100. Second month you are going to save 118.43. The third month you are going to save 118.43 plus 18.43, which is going to be 136.86. So this is the saving that you are required to do in the third month, and so on. And like this, if you go on doing for complete 24 months until your grandma's 75th birthday, you will have rupees 7,500 in your account to give to her. So this was a real world actual situation problem to calculate how much more money you have to save every month if you want to have a certain definite sum of money at the end of a definite period, like 24 months. I hope the topic and the example problem were well understood. And I am done from my side. If students and parents have any questions to ask, any clarifications are required, please feel free to ask me. Any questions, please? Students, parents, you want to know anything more about the classes? Thanks a lot for your time. I'll be sharing the feedback form shortly after the session is closed. And please, I request you to respond and give me your honest feedback. That will help me to improve from my side to customize the lesson, to customize the session to your requirements. So unless you give me a frank opinion, a frank feedback about your requirements, there will be a mismatch between what you wanted and what I will be doing. So please do fill up the feedback form and send the form to me as soon as you can. Thank you so much and goodbye.